Welcome to our follow-up question and answer review to our Brownstock Washing webinar series. We're here to discuss questions that couldn't be addressed during our original presentations. A link can be found below to the North America presentation, The Importance of Brownstock Washing and Dissolved Solids Optimization for Pulp Mill Efficiency. My name is David DiCorpo, and I'm a sales manager for the liquid measurement team at Vaisala. I'm here with our presenter, Kimmo Koivula. Kimmo, could you give us a quick introduction?
Thank you, David. Of course. So welcome everyone on my behalf as well. My name is Kimmo Koivula, and I work at Vaisala in sales today. My background is in the pulp and paper industry. I've been working in the industry for the last 15 years, and I'm here to answer the questions that you had during our webinar. So thank you all.
Thank you, Kimmo. Again, a link to the original presentation can be found below, along with our contact information. Please feel free to contact me or Kimmo with any additional questions. Let's begin with questions relating to our measurement technology. Is the measurement affected by the mix in the digester containing pulp and suspended solids?
Good question. So the answer is no. The refractometer is not affected by the mix of pulp or suspended solids. This is because of the measurement principle. We only measure the dissolved components. Good question.
Okay, thank you. Next question. Can you confirm total organic carbon is found as dissolved solid or suspended solid?
So we measure only the dissolved part, the liquid part, the liquid phase in the pulp slurry or in the liquor. And we measure this as a control parameter because this is what is really being washed away in the Brownstock washing line. So this is what we are really trying to separate from the fiber, and this is what we want to know when we assess Brownstock washing. So only the dissolved part.
Okay, thank you, Kimmo. This next question is interesting and has to do with references. TAPI has papers that reveal the conductivity is not a reliable indicator of soda loss into the bleach. This is part of your TDS measurement. Do you have any data that shows how the refractometer is superior to the conductivity measurement?
So yes, there are several papers that include these comparisons between conductivity and total dissolved solids. And in addition to those of TAPI that was mentioned, there are papers, for example, written by Riku Kopra et al., which include different comparisons between conductivity and total dissolved solids. Those papers can be found, for example, from our Vaisala website, and those can be reviewed there. There are many experiences in practice as well, showing how the total dissolved solids is a more convenient way and more convenient indicator of soda or organic material into the bleach. Currently, we are working with different mills to acquire more practical data that compare the conductivity and total dissolved solids to the bleach response and bleach chemical consumption as well.
Okay, thank you. Next question is related to measurement points. What is the minimum number of measurement points you recommend to get benefits of reduced carryover?
Yes, so this is a question that we hear oftentimes as well. So even a single refractometer can help with this reduction of carryover by giving a reliable measurement and controlling the water or the dilution factor according to this level. But then a more comprehensive set of measurements will help to reduce the carryover even further by stabilizing the carryover in the course of the entire line, and by making sure that each wash step is working in an optimal manner. So the more measurements we have, the better view and the better measurement we have from the whole washing line, and we can control that in a better manner. And when we have a better control of the whole washing line, for sure, we will have a better end result as well.
Okay. Last, relating to the sensor itself, I think, is, can I use a refractometer output to automatically adjust wash water amount going to the washer?
So yes, you can, and this is very often done as well. So you can adjust the water amount or the dilution factor if you wish. You can adjust that to a single washer, or you can adjust that for the whole washing line, or you can do both. So the refractometer, as it has 100% digital technology, it is not it's not affected by other process variables, and the calibration does not drift. And this is why it is used for process control automatically as well, because it is reliable.
Okay, Kimmo, thank you. Our next question is a little bit specific, relating to one of the process steps. How to measure pulp out from the pressure filter where pulp goes to repulper as a cake?
Good question. So pressure filters tend to have a very high consistency in the output of the filter. That is usually more than 30% of consistency. And this means that there is a very little water, very little liquid present in the pulp, and that is not enough for the refractometer measurement. So in these cases, it's preferable to install the refractometer after the repulping, after the press, or after the dilution, and there you have the total dissolved solids for the next stage. Or another option is to measure the total dissolved solids from the last filtrate coming out from the pressure filter. So this is used as an indicator that is very close to the actual pulp leaving the filter. But this always depends a bit of the actual setup of the pressure filter and what kind of repulping or dilution is used.
Sometimes the answer is it depends.
Yes, exactly.
Our next question brings us up to a 30,000 view of the pulp mill. Is there any difference from optimization point of view if the mill is running hardwood or softwood?
Okay, no, there is no difference from optimization or control point of view. So the refractometer has a slightly different calibration because of the chemical composition that is a bit different between hardwood and softwood, but from process optimization point of view, no difference.
Very good. Next question. How do you differentiate the TDS readout to reflect the variables, for example, after delignification step, since it measures everything and not just one component of the pulp?
Good question. So we measure with the refractometer, we measure the total dissolved solids, and this is used as a process control variable as such. So this is a very important parameter that has important and significant effect in the reactors, for example, and of course in the bleaching. So that is what is used for control. Then to differentiate the different parts in the liquor, in the total dissolved solids, we would need to use additional instrumentation as well. For example, conductivity, with the total dissolved solids and conductivity, we could calculate the inorganic and organic proportions as well. But if you would be interested in seeing this kind of proportion or details, please do let us know, send us a message or email, and we can discuss how to do this in practice.
Very good. And just a reminder again, contact details are listed below on the webinar interface. Next question is very practical, engineering-minded question. Do you connect the refractometer to DCS directly?
Yes, that is the most common way how to do it. The refractometer output is connected to the DCS, and usually 4 to 20 milliamperes are used, but also digital communications are available if that would be needed.
Excellent. Okay. Next, also from a connection standpoint, does Vaisala develop a sanitary version of the refractometer?
Oh, yes, we have different models of refractometers available. We have, for example, the sanitary model. We have like Teflon coated model for sulfuric acid measurements at the pulp mills as well, or other chemicals. But in general, for the pulp industry, we do recommend the retractable sensors that we saw that we have seen in these presentations, because they can be retracted, removed from the line without having to shut off the process or without having to use separate valves for the piping. So, and that's also recommended by Blurback. So that is why we recommend this solution to the pulp industry. But if you would be interested in some other model, well, we for sure are happy to discuss that as well.
Okay, thank you. The next set of questions are more focused on product. First, we have, what is response time for typical refractometer? So I suppose this is for a typical Vaisala refractometer.
Yes, for sure. So the refractometer takes a measurement every second. So it is really immediate response time.
And that's also data transmitted from the refractometers every second as well.
That is correct, yes.
Okay, thank you. Next question is, are there consistency maximums that the refractometer is limited to?
Yes, so the refractometers are used from low to medium consistency pulp slurries, so up to 15%. Then when we go to high consistency, that is practically, for example, pressure washers, wash presses, then the pulp slurry doesn't have enough liquid for the measurement.
Right.
So up to 15%.
And it is the liquid phase that we're measuring. So as that phase decreases, gives us more challenge.
Exactly.
Okay, we also have a group of questions here related to installation. The first one is, what are the most common installation problems?
So the refractometer as such is not affected by flow velocity, bubbles, turbulence. So that is why the installations can be done in a large variety of locations and in variety of ways. So it's not common to encounter problems, but some issues might occur when the prism is coated. If there is some kind of coating due to process disturbances, for example, if there's a lot of soap in the pipe, if there's a lot of variation, so this can happen. So if there's some coating in the prism, that will affect the measurement. And this is why we always deliver the refractometers for filtrate lines equipped with integrated wash nozzles, so that these can be used if any kind of prism coating would occur. And if any prism coating would occur, we do see that in the refractometer diagnostics, and the refractometer would indicate this. So it will tell you if everything is okay or not.
Very good, and that segues us very well into the next question, which is a wash system needed for pulp stock TDS measurement?
Okay, good question. So it's not needed. So in pulp stock installations, the fiber itself, it keeps on scrubbing the prism surface all the time, and it keeps it clean. So we have a lot of experience in these installations, and no prism cleaning is needed. Then for the installations in the filtrate lines, as I mentioned, we do provide the instruments equipped with an integral wash nozzle already, so that it can be taken into use if any kind of prism coating would occur.
Okay, very good. The last few questions here bring us to more of an engineering line of questioning. First is, does it matter if the sensor is installed in horizontal or vertical line?
Generally speaking, it doesn't matter. It doesn't matter if it's a vertical or a horizontal line. What is important is that the pipe is always full. And that's why oftentimes the refractometer is installed after a pump, for example, where we know that there's always process medium in the pipe.
Great. So location is important, but not the horizontal or vertical position.
Exactly. Yeah.
All right. Next question is, will the installation location for solids measurement be the same for batch and continuous digesters?
Yes, in general, the locations are the same because the material flows are the same as well. So we have the incoming cooking chemicals and chips, and then the outgoing pulp slurry. But there are some differences though between batch and continuous. For example, in continuous digester, the refractometer is used in liquor extraction, from where the liquor goes to the evaporation stage, and we measure the total dissolved solids there, which is also the total dilution of the solids in the entire line. Then in batch digesters, there are these recirculation lines, which circulates the liquor during the digesting process. And in these lines, the refractometer is used to monitor the growth of the total dissolved solids during the batch. And that's where we can see how much lignin is dissolved from the chips.
Okay, thank you, Kimmo. And here we are at our last question. Is the implementation of TDS to existing washers easy? Can we do it ourselves in the mills, or will Vaisala install them? Good
question. So the installation can be done by the mill during a shutdown. That's always needed, a shutdown. We do provide installation instructions and consultancy, which we recommend to follow carefully. And we do, basically in all the cases, we work together with the mill to provide the best installation location and best practices. And we can work with the third-party company that oftentimes do the installation, the mechanical installation and such. So we are there to help in this matter as well.
Well, Kimmo, we've come to the end of our list of questions. Thank you all for joining us for this follow-up question and answer program to our Brownstock Washing webinar series.